In this lesson, we'll look at how polarity and intermolecular forces affect something called miscibility. This is a property for liquids. This is also known as like dissolves like. So miscible liquids are basically able to dissolve in one another. And the reason that they can dissolve in one another is because they are alike in polarity. So polar liquids will dissolve in other polar liquids, nonpolar liquids in nonpolar liquids. This is where the phrase comes from, like dissolves like. They have to be alike in polarity. Here are two miscible liquids. This is antifreeze, which is made of ethylene glycol, and you can see that it is dissolving in water. They are mixing together, so they are miscible. So water is polar. That would mean ethylene glycol is also a polar molecule, and you can see that represented there in the particle diagram. But the polar water molecules would be attracted to the polar ethylene glycol molecules, and vice versa. Like dissolves like. Here are some other examples of polar liquids. Alcohols, which you can see here. I've shown you the structures. Methanol, ethanol, isopropyl alcohol. Basically, what do they all have in common? They have like a half a water molecule. That's what makes them an alcohol. What you don't see there are the lone pairs that would be on the oxygen, and you would then identify that as being polar. Acetic acid is vinegar. So vinegar does also dissolve in water if you use that for cleaning at all at home. Acetone, that's what's in nail polish remover. That is polar as well. Here's the structure. There's another oxygen. And again, what you're not seeing is the two lone pairs that would be on that oxygen atom. So that part of the molecule would be polar as well. Here are some examples of some nonpolar liquids. So anything that's greasy, oily, waxy, tar-like, those things tend to be nonpolar. Gasoline, which is octane, that's right here. That's a nonpolar molecule. These are much larger molecules shown here than the ones that we have looked at. But if you can kind of look and see a very symmetrical molecule, hopefully you can recognize that as being nonpolar. There's also some other what we call hydrocarbons here as well. So if things are not alike in polarity, we say they are immiscible. So polar and nonpolar do not mix. You can see here in this photo, we've got some liquids that have layered out because they are immiscible. So the C6H14, we call that hexane, that's right there. Again, hopefully you can see just a very symmetrical molecule. Nonpolar, water is here, of course with the lone pairs, that's polar. And then the carbon tetrachloride is right here. Again, no lone pairs on the central atom, so nonpolar. If we shook these up, we would probably get our two nonpolar ones to mix. They would be miscible. And then we would have a second layer that would be just the water. That's polar. Here are some more examples of immiscible liquids. Here's oil and water. So in particular, motor oil and water, you can see they are layering out. The water molecules are not strongly attracted to the hydrocarbons that make up the motor oil. The water molecules are more attracted to each other than they are to the hydrocarbons. And so they layer out. So I'd like you to take a look at these three liquids here. We want to talk about them being miscible in water. And water, again, we just looked at that previously. Water is polar. So we would like to find some liquids from our list here that are polar as well, and they would be miscible. I'd like you to pause the video here, draw the Lewis dot structures. This is CI4 right here, by the way, and see if you can figure out if they are polar or nonpolar. And again, the polar ones would be miscible in water. Okay, so pause the video here and draw out those structures. So here are our Lewis dot structures. You can see that the SCl2 has lone pairs on the central atom, and so that would be polar. The BCl3 does not. Remember, boron is an exception to the octet rule and only needs 6. And then the Ci4 also does not have lone pairs on the central atom. So both the BCl3 and the Ci4 would be nonpolar. They would be immiscible with water. The SCl2 is polar and would be miscible with water. So hopefully now you know what miscibility is and how to determine if two liquids are miscible or immiscible.